Hi everyone, have a good day. I am K. Surya, working as Assistant Professor in the Department of ECE at SNS College of Technology. So the next topic in this lecture series is frequency reuse under the unit Fundamentals of Wireless Communication. So now let us explain this frequency reuse topic in a design thinking manner. So design thinking is nothing but a method to enhance the thinking capability of the students. So under design thinking we have five stages. The first one is empathy, then define, ideate, then solution, and then testing. So you will explain this frequency reuse concept in a design thinking manner. So the empathy part, most networks today are under stress due to growing broadband traffic. The networks that are easily the most stressed are the cellular networks. And I think that there can be lessons learned in looking how mobile providers are struggling to keep up with demand. The main issue faced by the cellular network owners is uh, traffic volume growth. So around the world, cellular networks are seeing between 60% to 130% annual growth in data volumes. The problem with that kind of growth is that as soon as any upgrade is made to a part of the network, it is consumed by the growth. This kind of growth means constant choke points in the network and problems encountered by the customers. The large cellular companies like Verizon and AT&T are handling this with big annual capital budgets for network improvements. But they will be the first to tell you that even with those expenditures, they are only putting band-aids on the problem and are not able to get ahead of the demand curve. So let us define the problem statement. So early mobile radio systems uses large high power transmitters to cover large areas. So frequency reuse was not possible here, which will cause more interference. It is not impossible. It is impossible to reuse the frequencies because of large area coverage and high power transmitters. So, in order to improve the demands of the users, in order to increase the capacity of the network, they were thinking what we can do, and finally, they came to an idea that frequency can be reused. So the same frequency can be reused again and again because the available spectrum is also very limited. You cannot each and every time when the users keep on growing, we cannot go for a new spectrum. So this idea of frequency reuse was better suited for the cellular networks. So frequency reuse is a system level idea where we'll be replacing a single high power transmitter with many low power small transmitters, which each transmitter will providing coverage to only a small portion of the area. So only we are dividing the entire area into small cells, and for each cell we are providing a base station where you will be having low power antennas for transmission and reception. So each base station is allocated a portion of the total number of channels available by the entire system. Similarly, neighboring base stations should not be allocated with the same frequencies. Neighboring base stations should be assigned with different groups of frequencies in order to avoid adjacent channel interference. As I told you already, a cluster is nothing but a group of cells. So within a cluster, two cells should not have the same frequency in order to avoid adjacent channel interference. So in frequency reuse, you know that cell is nothing but a geographical unit of a cellular network, and it is the area around an antenna where a specific frequency range is used. So when a subscriber moves to another cell, the antenna of the new cell will take over the charge, and the call will become disconnected from the old cell. Uh, The frequency spectrum is divided into subbands and each subband is used within one cell of the cluster. In heavy traffic zones, cells are smaller, while in less traffic zones, cells are larger. So this is how the frequency is reused. So you consider your cluster size is 7. So within a cluster you will be having 7 cells. So A, B, C, D, E, F and G form a cluster. So A will have one set of frequency, B will have another set of frequency. So all the 7 cells inside the cluster will be having different sets of frequencies. The total available spectrum here, it will be divided into 7 equal parts and each cell will be allocated with one particular set of frequency bands. The same frequencies will be reused in the next cluster. So this is how frequency is reused here. So there is a pattern of frequency reuse which we'll see later in this video. So the design process of selecting and allocating the channel groups for all the cellular base stations within a particular network is known as frequency reuse or frequency planning. So each cellular base station is allocated with a group of channels within a small geographic area called a cell. Neighboring cells are assigned with different channel groups. By limiting the coverage area to within the boundary of the cell, the channel groups may be reused to cover different cells. So let us see how the frequency reuse is characterized. Consider totally you're having S duplex channels and each cell is allocated with K channels where K should be less than S. So the S channels are divided among N cells where N is the cluster size. So if N is equal to 7, then available spectrum will be divided by 7. If it is 4, then it is divided by 4. So the total number of available radio channels can be represented by S is equal to K into N. So this cluster is repeated many times. Say it is repeated m times, then the total number of channels of a network or the capacity it is given by capital M into K into N or M into S. So the capacity is directly proportional to the number of times the cluster is repeated. So the cluster size N can be chosen using the formula I square plus ij plus j square. So the I and j values, when you substitute it here, you will be getting the cluster size and small n is a symbol for maximum capacity. The frequency reuse factor it is given by 1 by n. So hexagonal geometry has exactly 6 equidistant neighbors. The line joining the centers of any cell and each of its neighbors are separated by multiples of 60 degrees. So these are examples when I is equal to 1 and j is equal to 1 and when you substitute n is equal to I square plus ij plus j square, you will be getting cluster size as 3. Similarly, you'll be getting cluster size of 7 when I is equal to 1 and j is equal to 2 or I is equal to 2 and j is equal to 1. So this is uh, diagram which shows how you can reuse the frequency. So what you will do here is you have to move I cells along any chain of the hexagon. Say for consider this one. So you will be moving I here it is equal to 3 and j is equal to 2 so that n is equal to 19. So you are moving 3 cells 1, 2, 3. Next step is turn 60 degrees and in the counterclockwise direction and you have to move j cells. J is 2, 1, 2. Okay. So move I cells along the direction, turn 60 degrees anti-clockwise and move j cells. So 1, 2, 3, turn 1, 2. So this is how frequency reuse pattern is followed. So this is followed because you have to maintain a certain distance between the co-channel cells in order to avoid co-channel interference. So co-channel cells are nothing but the cells having the same frequency. So for example, this A will be having 1, 2, 3, 4, 5, 6. So totally 6 co-channel cells. So advantage here is it will solve the spectral congestion and the capacity will get increased. So limited spectrum is utilized and more number of times you are using the available channels, not to increase the capacity. Uh, so large number of users can be accommodated in the network. So frequency reuse is very advantageous, not to increase the capacity of a network. One important thing you have to consider here is allocating of the same frequency in the neighboring cluster. You have to follow the pattern of frequency reuse. And this will avoid handoffs, it will reduce the interference, and it also channels are distributed in time and space where all the zones are also reused in the co-channel cells. Hope you understood frequency reuse. We will take few assessment questions. Why neighboring stations are assigned different group of channels in the cellular system? The choices are to minimize the interference, to minimize the area, to maximize the throughput, to maximize the capacity of each cell. Yes, the answer is to minimize the interference. Next one is what is frequency reuse? The choices are process of selecting and allocating the channels, process of selection of mobile users, process of selecting frequency of mobile equipment, process of selection of number of cells. Yes, frequency reuse is nothing but the process of selecting and allocating the channels. Thank you for watching this video.